Okay, dear friend, this time in this second video I will show you how to add support to this OLED screen and to record, to display any information on this screen. So we already configured with the Visual Studio Code our program. We have our program named demo, and now we want to add this library. So this library is called U8g2 by OLED. So you can copy this name, U8g2. It supports a wide range of displays. Our display is in SSD1306, and it can display into graphic format or in 8 by 8 pixels. So this one is rather fast and it consumes not a lot of memory, and this one is more beautiful, but it will take a lot of memory, as we will show you later. So if we compile our program, we will see how much memory this program takes. So the usage is 34% of RAM and 27% of flash memory, and we will compare this when we deal with the other one. So first of all, we switch back to our program, and what we want here is to add libraries. So you can do like this or go to libraries. It depends on what do you want to do. So let me just put this in small size so you can see, and here we can type our library name and we search it. So we find it, it's given by Oliver. Okay, so we click on it and we add it to the project. And take attention here to the file PlatformIO. Here we have no library, and when we ask to add it to the project, it asks us what name of the project we have. So it's our demo project. You don't need to bother yourself with this, and you just click add with the latest version. So now it is downloading the library, and it is also adding here library dependencies, and you can see in the directory here that it adds the U8g2 library in the directory. Okay, so now you can go here and to see how you can use it, for example, or you just follow my code. So I already put code here. So first of all, I will use this include, and then I specifically add this. Okay. So these two lines say to the Arduino program that we will use the U8g2 with a hardware I2C link. So it is the fastest one. And we have to specify which is the serial clock and serial data that we will use for this I2C. So it's pin D1 and D2. So here, if you look at the screen, you see that you have serial clock and serial data, and you have to connect them to the D2 and D1 connection here, as you can see in the white and the black. So you have D3, D2 and D1, and you need to connect, of course, the ground to the ground. And the voltage, I use 3.3 volt over there. As you can see, I use 3.3 volt. Okay, this is how we initialize it. So let's come back to our program, and we will add from the routine remaining here for the setup. Okay, just to, now we take this one, move it with only one tab, and we can let the loop as it is. Okay, I'm printing twice. So first of all, we begin with the serial begin. So it configures the serial port for 115, 200 bots, so bit per second. Then it's also configured the LED built-in output as an output, which is the LED here over there. We don't use it here. We can toggle it later. And we specify which font. So with the begin here, it will configure the I2C and the library as we specified here at U8g2. So all the orders using U8g2 must begin with this. U8g2, then dot, and then you can have, I clicked on control space, and then you can have all the instruction, the function of this library. So the first one, which is the begin for the configuration and initialization of this library, then we ask which type of font. So here it is Helvetica of 12 pixel height. So you have many of them. Okay, as you can see, you can choose one of them. Then you select the font mode. So if you click Control, it will say to you which kind of font mode, is it transparent or not. So this is documented. Go with the reference manual, and we go to the begin, and after that you see here that the coordinate is from the beginning of the letter. And let's come back here, set font mode. Then you click on set font mode, and it is said that the argument, if you use the transparent, that means that it will draw on the buffer and you will not erase what is already drawn. So we define if the string drawing mode will write the background color, is it transparent or not. So if wait one. So I prefer this. And then before writing, we clear the buffer. So the buffer is a memory corresponding to what we are drawing. So we first draw to the memory. So this is why it takes memory space in RAM. And then this buffer is transferred to the screen when it is encountered the instruction send buffer. So first of all, we go to X0 and Y16, and then we will write IoT demo. So this will be wrote in the memory, sent to the buffer, so it will be displayed on the screen, and this will be on the serial. Okay, so just let's compile and flash with this arrow. So the first time it will recompile again using the library, so it will take time. But if you do not add a new library, that the compilation time will be not so much. Okay. So let's zoom a little bit. Now it is flashing the memory, so you can notice that it took much spaces, so 36% and 28%. And now you see it. So you see this IoT demo that is written here on the screen. So what we succeeded now is to write something on the screen. We can also write a second line. For example, we go if we want to write it many times or only once. Is we want, for example, to add a new variable. Let's write here int equal 0. And in my screen loop, in my loop, I will increment this I, and I will display it a equal plus convert this integer to a string, and then I will take this buffered line, clear buffer from clear buffer line up to send buffer, and I will put it to my main loop. So I will also keep the IoT demo, but instead of 0 to 16, I will display somewhere down plus string, converting the integer to a string. So I am adding this true string I equal and the value of I, and I am displaying them on the first line and on the second line. So let's send it to the flash memory. So the process of compilation is much faster, and there is only the process of flashing that is taking time. Okay, so now we will go and look to our program here. It's a demonstration. As you can see, now it is incrementing. So thank you for watching this episode of how we use the Wemos ESP8266 with an OLED screen and Visual Studio Code, how we learned how we add libraries, and until next time, see you. So the next time we will deal with Wi-Fi connection.